This is going to be a short tutorial on how to use async annotation in Spring Boot to make any method asynchronous and how to test it. So let's go. There are two main use cases where you could or should use asynchronous programming. Number one is to increase the performance of your program by executing tasks in parallel. And number two, executing an optional task which takes too long to complete. And by optional, I mean the result of a task does not matter to the outcome of the current process. Let's look at use case number one while brewing a nice hot cup of coffee. Brewing a coffee is a two-step process. First, we need to grind the beans into powder, and then we need to put this powder into the machine, and the machine will spit out the coffee for us. Let's look at our async application to see how we brew a coffee. The code and the links you will find in the description below. In this application, we have a coffee grinder service. This service has a method grind coffee beans, which basically grinds the coffee, returns the powder. The implementation is pretty simple. It just returns a string coffee powder for the sake of simplicity. And to simulate real work, I have a thread of sleep where it takes 200 milliseconds to finish the process. Then for the coffee machine, I have a coffee machine service interface. The implementation is very similar. It just takes the coffee powder that was grinded using the coffee grinder service and then makes the coffee for us. It again sleeps 200 milliseconds to simulate making a coffee. And then we have the coffee service to which we pass a parameter how many number of coffees do we want. And the implementation is also pretty simple. It starts by noting the time when it starts, then it loops for the number of times, grinding the coffee, and then it makes the coffee with the beans that were grinded, and then it notes the time that it takes to finish the process and then logs how long it took to make the coffee. Let's run the test. In the test, I will pass the parameter number of coffees to be 10, and let's see how long it takes. Here's the result of running the test. It took 4 seconds to brew 10 coffees. So 200 milliseconds plus 200 milliseconds is equal to 400 milliseconds to brew one coffee times 10. That's 4 seconds. Let's see if we can make it faster by parallelizing the brewing and the making of the coffee. To make the coffee faster, what we can do is, while the coffee machine is brewing the coffee, we can grind the powder for the next coffee in parallel. So that will reduce the time it takes to make all the 10 coffees. Let's see how it is done in our program. The first step to enable parallelization in Spring Boot is to use the annotation enable async. Once we have used this annotation, we can go back to our interface coffee grinder service and mark the method grind coffee beans with the annotation async. The async annotation can be applied on an interface method or on the whole class, and all the methods are async. But you have to remember that the return type of the method must be of type void or future, and completable future is a concrete implementation of future. The real implementation of grind coffee beans doesn't change really much, just the signature changes, and the return type becomes completable future dot completed future and the value that would have been returned. So that's all, and this method is now async. It will run in a different thread. We do similar to the coffee machine service, apply the annotation async, go to the implementation, and instead of returning, because there was nothing to return, it was void, all we do is we return completed future null. And this is how our coffee service implement looks now. The brew coffee method will start with grinding the coffee powder for the first coffee. After that, it can use that coffee to make the first coffee, and at the same time, it can grind the powder for the next coffee. This happens in the private method, make coffee, and at the same time, grind beans for the next. And this is how the async functionality in Spring Boot works. So what you do is you call the two methods, make coffee in the coffee machine service and the grind coffee beans in the coffee grinder service. And all you have to do after that is call completablefuture.allof and pass in all these completable futures that you created before. And the all-of method will wait till all the futures are finished and then return. And once it returns that you know that all the methods are finished, you can extract the value that you need and pass it back to your brew coffee so that it can call this method again with the new powder. And the cycle repeats itself till all the 10 coffees are done. And now let's look how fast the test will run. And here's the result of our test that we ran before. As you can see, we could brew our 10 coffees in 2 seconds instead of 4, just by parallelizing the tasks that we could. Now let's look at the second use case we talked about in the beginning, which is executing a task which is optional. Optional means we don't care how long this task takes, and we don't care if this task finishes or not, if there's an error. Let's say while brewing the coffee, we want to start the dishwasher, and we don't care if the dishwasher runs, how long it runs, few hours, or if the cycle breaks in between. In our code, we have a dishwasher service, which is a method start dishwasher. The implementation throws an exception. Why not? We don't care how long it runs. We don't care if it fails. If we now go back to our coffee service and somewhere in our code, let's say here, auto wire the dishwasher service, and then we somewhere in between say dishwasher service start dishwasher. What will happen is this will break our test. Let's run our test. As you can see, it fails with runtime exception. Why not? How do we avoid that? Because we don't really care if the dishwasher runs or not. We go back to our dishwasher service, and all we have to do, because the method return type is void, we don't even have to use completable future. All we do is we annotate this method with async. After that, we can go back to our test, run the test again, and the test works. There are no errors. Here you can see the result in the log file. It took 2 seconds to brew 10 coffees, but after some time there was an error. Runtime exception, why not? But it was completely ignored by our main thread because it ran asynchronously in a different thread. Let's see how we can write tests for these async methods. Remember, we saw 2 different types of asyncs. One where the return type was void, and the other where there was a different kind of return type and it had to be changed to completable future. Let's look at the completable future first. So this is our coffee grinder service, which has a method grind coffee beans, which returns completable future and has been annotated with async. Let's look at the test. In the test, we call the grind coffee beans, get a handle on the future, and then do an assert equals. Because we have a handle on the thread in which this method is going to run, it really doesn't matter how long it takes or if it's in a different thread. The future.get, if you look at the Java doc, will wait if necessary for this future to complete and return the result, and then we can do a simple assert. So writing a test for these kinds of async methods is not really different than writing a normal synchronized test. Let's look at the other type of async we saw, where the method return type is void and the only thing we had to do was to annotate this method with async. Remember the dishwasher service. So it has a method start dishwasher, which we annotated with async, and the implementation simply throws a runtime exception. Now I would like to test it. So I write my test as I wrote the other test. I call this method and then I expect a runtime exception to be thrown, and I know the message, so I do an assert. Let's run this test. The test fails, and the reason is obvious, because we do not have a handle on the thread where it failed. The exception was thrown, but we never got the exception back in the test, so we could do this assert and compare the message that was set in the exception. So what can we do? To test these kinds of methods, we can use async caught exception handler. If you look at the Java doc, it says that when the method does not provide the return type future, this handler can be used to manage such uncaught exceptions. This handler has a method handle uncaught exception. For the sake of convenience, we have a static map with the thrown exceptions, where we will take the exception that was thrown and put it in the map with method name as a key. Now, how do we use it? To use it, we need to create a new async config in our test scope, which will implement async configurer. And this interface has a method getAsyncUncaught where we will provide our newly created exception handler. Once we have that set up, we can go back to our test and rewrite the test. So now we'll just call the method and we do a thread.sleep to wait for the other thread to finish where the exception will be thrown. And after that, we can get the thrown exceptions by calling our exception handler.getThrownExceptions, and there we can just check if our exception is there as expected. And let's run the test and see, and it works. To recap, we saw when and why to use asynchronous programming, and then we saw two different ways of introducing asynchronous programming in our code, and in the end we saw how to test these methods. If you liked what you saw, like, subscribe and leave a comment. Thanks.